So let's suppose we want to find the exact value of a trig function, and it could be any of the trig functions. I'm going to do secant in this example. The first thing is to look at the angle and to make sure you understand what the angle represents. In this case, negative 2 pi over 3 means a clockwise rotation, because if I had positive 2 pi over 3, I would be rotating this way, and I would end up with a terminal side right here. So this would be an angle of positive 2 pi over 3. Negative 2 pi over 3 is just going to go exactly the opposite direction. So rotating clockwise around here, the same amount of rotation, just going the opposite direction. So negative 2 pi over 3 is this angle here. But both of these share some common attributes. For instance, we know from the unit circle that the coordinates of this point would be negative 1/2 and root 3 over 2. That means that from symmetry, this point down here is also negative 1/2, but negative root 3 over 2. So it's pretty easy to find the secant of either the positive or the negative angle. I just need to know which quadrant I'm in so that I have the correct values of these variables. Then I know that secant is the reciprocal of cosine. That means that the secant of an angle is x over, oh, almost made a mistake there. That would be cosine, r over x. So cosine is x over r, so secant is r over x. I know all of these variables because r on the unit circle will always be 1, and the x value is negative 1/2. So I have all of the information that I need. I have r and I have x. So here's my x, here's my r. So I can go over and plug that in. And so I would have 1 over negative 1/2. And notice that I made this fraction bar bigger because this is the main fraction. 1 over anything is really just the reciprocal. And the reciprocal of negative 1/2 would be negative 2 over 1, which is just negative 2. So in the end, the secant of negative 2 pi over 3 is negative 2. And all of the 6 trig functions can be evaluated for the special angles in the same manner using the unit circle.